So this is the board that we're given. It's a 5 cross 5 matrix in which we need to place 5 queens, right? So let's take a function, say queens, that will place the queens in this board. So this function will need the board, the column index, let's call it call, and the size. Size is 5. Now here, as we're going column by column, we're going to run a for loop for each column to select the row at which we can place the queen for that column. Okay, so let's take the for loop for I is row here, so I in range size, So in this loop, first for the cell, we will check if we can place the queen at that cell or not. So for that, we will create this isSafe function, and this function will need the board, it will need the row, which is I, and it will need the column index. If we can place the queen at the cell, then we will mark the cell 1. So at this cell, put 1. So this is the cell where we have placed the queen, but before that, let's implement a save function. So think about how we can check if the current cell is the right placement for the queen or not. So at the current column, we have already traversed all the columns coming before it. Okay, so there can be queens present only at the left to the current column, right? There will be no queen present to the right of the current column. So we will only see at the left. And now first we will see if there is a queen present horizontally to the current cell. So row will be same, right? Row will be same and column will be any column coming left to the current column. So let's take a for loop for I in range column. So we will go till the current column only. And now we will check if the board will keep the row same and we will change the I each time. That is, we will change the column each time is 1. So that means if there is any queen present horizontally, then we will return false. We will also be needing size here. I forgot to take size. Next, we need to check if there is any queen present diagonally left to the current placement. So we have upper half and the lower half. So first we will check for upper half. So if we are checking for the upper half, that means we have to decrement the row and column by 1 each time. For example, if we are currently at 2, 2, then we have to go to 1, 1, right? So for I, comma j, and we're gonna use zip here. So first for I, it should start from the current row, go till it is less than -1, and the step size is -1. And for column, it must start from col -1, step size is -1. So if board ij is already having the queen, then return false. Okay, now for lower half, so we need to go in this way. Okay, so for lower half, you can see the column will decrease by 1 each time and the row will increase by 1 each time. So let's write for lower half. For ij, this will go till the size, and the step size will be +1. This will go to -1 and the step size will be -1. So now if there's any queen present there at any cell, we will return false, else this is the right placement, so we will return true. Now coming back to the save queens function, here see we have placed the queen here. Now we have to make further moves. We have to go to the next column to do the same stuff. So here we will recursively call if save queens with all the parameters. We will pass the board, we will pass call. We have to increment the column by 1. We have to check for the next column, and size is size. So if this returns true, return true. Else we need to backtrack, because we have to change our decision for this cell back to 0. We will not be having the queen at this cell. And finally, for outside of this for, if nothing is working out, we will return false. Now the base case is when we reach to our goal, and this is when we have traversed all the columns. So if call is greater than equal to size, then return true. Now let's take this board and let's take it here, and now let's uncomment it. So now we will call this save queens method by passing this board, save queens. Let's pass the board, and initially the column index is 0, and we gotta pass the size, which is the length of this matrix. This is the size. So let's pass the size. If this returns false, then we will print that the solution does not exist. Solution does not exist. Else we will print values for all the cells. Else let's take the for loop for I in board, for j in I, print j with space and with and change the line. So now let's run this and see the placements of queens that we get. Yeah, we need to pass size here as well. So let's rerun this. So this is the board and the placements of queens, and the queens are not attacking each other.